Hi guys, welcome back to VBC Academy, the virtual classroom of Virendra Bob. In last series of lectures, we have seen about the light reflection at curved surfaces, the first chapter. In today's session, we are going to have a new series of lectures. We are going to start a new series of lectures in today's session. On the topic we are going to discuss is the light refraction at curved surfaces. Okay, so in this series of lectures, we will be having 4 to 5 lectures. We will be covering the entire concepts of refraction at curved surface. And before going to start this session, once again I request you people, if you have not subscribed my channel, please subscribe the channel and share this information among your friends and colleagues and relatives so that everyone can access my classes. Okay. So without wasting much time, let us start today's session on the refraction. Okay, let us observe this picture. The brush placed in water is bended and is bulged. Yes or no? Why? Because it is due to refraction. So technically speaking, what is refraction? Let us elaborate this one. When a light ray passes from air medium to water medium, instead of passing in the form of a straight line, it changes its direction, means it bends. So bending of light, when the light ray passes from one medium to another medium, is called a refraction. Or the change in the direction of light ray when it travels from one medium to another medium is called as a refraction. During diffraction, the light ray bends. Now why it bends? It is because of the change in the speed of light. Okay, so the speed of light changes when light travels from one medium to another medium. Similarly, the speed of light is more in a rarer medium than in a denser medium. Here we are going to introduce two new terms. One is rarer medium and denser medium. What is mean by rarer medium and denser medium? Let us see the definitions. A denser medium is a medium in which speed of light is less. Okay, so examples for denser medium is glass or water. In these two mediums, speed of light is less than air. So when compared to air, glass or water mediums are denser mediums. Similarly, the rarer medium, it is a medium in which the speed of light is more. So with respect to glass or water medium, speed of light is more in air medium or vacuum. So air or vacuum are the rarer mediums when compared to water and glass mediums. Okay, so let us have the basic definitions of a rarer medium and denser medium. A rarer medium is the medium in which speed of light is more. Denser medium is a medium in which speed of light is less. Okay, are you able to get my point? Here I am allowing the light ray to pass from the air medium to water medium, that is rarer medium to denser medium. Let us say this is what the light ray incidenting on the denser medium. Instead of passing in the form of straight line, it will bend. Okay, to analyze this particular bending of light, let us draw the normal at the point of incidence. Angle made by the incident ray with the normal is called angle of incidence. Now light ray, it bends. Okay, after bending, it passes like this in this case. Okay, so angle made by the refracted ray with the normal is called as angle of refraction. So angle of incidence is the angle made by the incident ray with the normal, and angle of refraction means the angle made by the refracted ray with the normal. All these angles are measured with respect to normal. Okay, this is what the basic concept of a refraction. Now refraction phenomena can be studied in two cases. When the light rays are moving from rarer medium to denser medium, the concepts are little bit differ, and the same concepts can also be studied when the light rays are moving from denser medium to rarer medium. Okay, let us start our discussion. First of all, we will discuss on the light rays traveling from rarer medium to denser medium. Okay, so what happens when a light ray travels from rarer medium to denser medium, it bends towards the normal. Why? Because its speed decreases. You know, rarer medium is a medium where the speed is more. Okay, denser medium is the medium where the speed of light is less. So when the light ray moves from a rarer medium to denser medium, speed is decreasing. So it chooses the shorter path. So let us consider the incident ray which has to travel in this direction. Instead of preferring this particular path, it prefers to travel in this particular direction. Here it is bending towards the normal. The light rays are bending towards the normal because speed is decreasing. So again the same concept, angle of refraction. Here interesting point we have to observe is, as the angle of incidence decreases, angle of refraction also decreases. Okay, so if you allow the light ray to pass along the normal, instead of refraction, the light ray also passes through the normal in a denser medium. That is, as the angle of incidence becomes 0, angle of refraction also becomes 0 in this particular case. Okay, now we will discuss about the refraction of light at the curved surfaces. Here the case I am going to discuss is, light rays are moving from rarer medium to denser medium through convex surface. Okay, so let us take the rarer medium is outside. This is what the denser medium. Okay, this is what the convex surface. Okay, this is what the convex surface. This is the convex surface, and this is the center of curvature of this particular convex surface. Let us assume, if the light rays incidence on this convex surface, light rays are moving rarer medium to denser medium. Okay, so instead of passing in the form of a straight line, they will bend. Okay, so they will bend towards the normal. That's what we have seen. Okay, so at the point of incidence, let us draw the normal. Normal is nothing but the line passing through the center of curvature. Here the light rays, after entering into the denser medium, they bend. In which direction they will bend? They bend towards the normal like this. So when the light rays passes from rarer medium to denser medium through convex surface, it bends towards the principal axis. Hence the surface acts as converging surface. Okay, let us see the next case. The light rays are moving from same rarer medium to denser medium, but through concave surface. If they passes through the concave surface, what happens? Here you see, this is what the concave surface. This surface is the concave surface. Okay, now this is the rarer medium, this is the denser medium. Okay, and this is the center of curvature of this concave surface. Okay, now light rays are now passing from rarer medium to denser medium through concave surface. Instead of passing in the form of straight line, they bend. So at the point of incidence, first step, we have to draw the normal. I have drawn the normal which is passing through the center of curvature. Okay, now here is the normal. The light ray enters into the denser medium but bends towards the normal, means here it bends towards the normal like this. Okay, so this is what important. So in this case, light rays are moving away from the principal axis. This is the principal axis. So these are diverging. So concave surface acts as the diverging surface when the light rays are moving from rarer medium to denser medium. Okay, now we will discuss about the refraction when the light rays moves from denser medium to rarer medium. Previously we discussed about the light rays moving from rarer to denser. Now we will discuss about denser to rarer medium. Okay, so when the light rays moves from denser medium to rarer medium, it bends, the light rays bends away from the normal. Why? Because its speed increases. Okay, we have taken the denser medium and rarer medium. This is what the incident ray, the light ray which has to pass in the straight direction. Instead of that, what happens? It bends away from the normal. You see, here is the normal. The light ray bends in this direction, means it is moving away from the normal. So whenever the light ray moves from denser medium to a rarer medium, as its speed increases, it prefers longer path, hence it passes away from the normal. Okay, when the light rays are traveling from denser medium to rarer medium through convex surface, what happens? Let us see. This is the denser medium, rarer medium, and this is the convex surface. Okay, so through this convex surface, if the light rays passes, what happens? Here you see, for this convex surface, center of curvature lies here. Okay, so when the light rays are passing through the convex surface, what happens? Instead of passing in this particular direction, here I have drawn the normal at the point of incidence. Here you see the light rays moves away from the normal. This is what the normal. So away from the normal means this path. Okay, so when the light rays are preferring this path, means they are diverging. So this convex surface acts as a diverging surface. So when the light rays are moving from denser medium to rarer medium through convex surface, this convex surface acts as diverging surface. Light rays are diverged. Okay, the last one, when the light rays are traveling from denser medium to rarer medium through concave surface, what happens? You see, this is what the denser medium, this is the rarer medium, and this is the concave surface, and this is the center of curvature of this particular concave surface. When the light rays passes like this, instead of traveling in the form of straight line, they bends, but away from the normal. If they bends away from the normal, means in this direction. Okay, so this surface is acting as converging surface. Here light rays are converged and moves towards the principal axis. Okay, in this way the convex surfaces and concave surfaces acts as diverging and converging surfaces based on the mediums. This is what we have seen. Okay, so let us conclusions of our today's session is, we have discussed the basic definition of refraction. We have also seen the types of medias, that is denser medium and rarer medium, and the converging nature of the convex and concave surfaces, as well as the diverging nature of concave and convex surfaces we have seen.